Hello, I am Dr. Uksun Kim. In this video, we will be discussing the equilibrium in 2D force systems. This slide shows the overview of my lecture. In the beginning, I will talk about the definition of static equilibrium. Then you will learn about the 2D coplanar force systems, equilibrium equations, and procedure for analysis. After these slides, I will solve an example problem with detailed explanation. Finally, I will provide a practice problem to check the level of your understanding related to this topic. The definition of static equilibrium is an object remain at rest if originally at rest. Now, I will explain about 2D coplanar force system and equilibrium equations. If an object is subjected to a system of coplanar forces in the xy plane, then each force can be resolved into its x and y components. So for example, F1, this is the x component, and this is the y component. Then for F2, this is the x component, and this is the y component. And then you can do the same thing for the F3 and F4. With this, equilibrium can be obtained if sigma Fa is equal 0 and sigma Fy equals 0. These equations are called as equilibrium equations. This slide shows the procedure for analysis. The first step is to draw a free body diagram. That's a very important procedure. And then step 2 is to establish the equations of equilibrium. This is one of the main topics for this video. And third step is to determine the unknown forces. This slide gives an example problem. This problem is asked to determine the tension forces. So tendon forces, that one is the cables of TCA, TCB, and then TDC, and then TDE of the chord system. To solve this example problem, we need to draw free body diagram at D and SC. So free body diagram at D and the SC. This slide shows the free body diagram at D and C. So you can learn how to draw free body diagram from another video clip about the free body diagram. So this is a free body diagram at D. That one is this one. Okay, in this one. And then free body diagram at C. This one. Using the free body diagram at D, you can formulate the equilibrium equations. So sigma F x equals 0. So that one is that the TDE cosine 20 degree minus TDC equal 0. And then sigma Fy equals 0. That one is the TDE sine 20 degree. Okay. And minus mg equals 0. So there is a equation 1 and there is a equation 2. So from equation 2, we can say that the 0.342 TDE equals mg. So from this one, TDE equal 2.924 mg. So that is the answer for the TDE. And then from 1, TDC equal 2.924 mg and cosine 20 degree. That one gives a TDC equal 2.748 mg. So this is the answer for that. And then free body diagram SC, you can also formulate the equilibrium equation, sigma f x equals 0. So that one is the TCD minus TCA times 3/5 minus TCB cosine 40 degree equal 0. So that one is the equation number 3. And sigma Fy equals 0. So that one is the TCA times 4/5 minus TCB sine 40 degree equal 0. That one is the 4. So from the 4, okay, TCA equal 5/4, TCB sine 40 degree. That means that the 0.803 TCB. From 3, TCD is that from the previous step, 2.748 mg minus 3/5 and then 0.803 TCB minus 0.766 TCB equal 0. So using this one, 2.748 mg minus 1.248 TCB equal 0. So TCB equals 2.202 mg. And then TCA equal 0.803 and then 2.202 mg. So TCA equal 1.768 mg. Then that's a TCA. So we can find all four unknown tension forces. This slide shows the practice problem. At first, you need to draw free-body diagram at O, free-body diagram. Then you need to formulate the equilibrium equations. And using the equilibrium equations, you can determine the magnitude of the F1 and then its angle theta. I hope this video is helpful for you. Thank you.